Think math.
This equation is a little different. 4 to the x minus 5 times 2 to the x plus 4 equals 0. There are two exponential terms sitting there. Even if you match the bases, they do not collapse into a single term. So what do? There is one thing to notice here. 4 is 2 squared, so 4 to the x is 2 squared, all raised to the x, which is 2 to the 2x. And 2 to the 2x is the same as 2 to the x squared. The two terms were really one term and it's square all along. So let us give 2 to the x a name. Call it t. Then 4 to the x becomes the square of t, and the equation reads t squared minus 5t plus 4 equals 0. The exponential equation has turned into an ordinary quadratic. Now factor it, and you get the product of t minus 1 and t minus 4 equals 0. So t is 1, or t is 4. Do not stop here. What we wanted was not t, but x. Since t was 2 to the x, we have to change back. If 2 to the x is 1, then x is 0. If 2 to the x is 4, then x is 2. The answer is x equals 0 or x equals 2. There is one condition attached. Because t is a power of 2, t is always positive. So if the quadratic hands you a root that is not positive, that root must be thrown away. Suppose the quadratic gave you -4. No power of 2 can ever equal -4, so there is no such x. To sum up, even when several exponential terms appear, if one of them is a power of another, a substitution ties them together. Switch to t, solve the quadratic, always change back to the exponent, and check that t is positive. A substitution is not a new calculation. It is dressing the problem in a shape you already know. A sip of math every day with Think Math.